Hello all, welcome to the session on data science. This is an introduction session, and as part of this session, we will look into what is a data science and machine learning and how it is different from a rule-based engine. And we will see a little bit of case study, and we will see how a case study, in the case study, how a rule-based engine is different from a data science machine learning based solution. And we will also see the technology stack. So, what is the environment where we can build the machine learning, and also various stages in machine learning? Okay. So, for example, it consists of starting from a data extraction, data pre-processing, etc. We will see what are the core stages of machine learning, and followed by the some overview of high-level overview of what are the types of ML algorithms and where it is being used currently. Now, I will also, as a part of this session, I will also walk you through on what is a Jupyter Anaconda-based Jupyter environment where you can write Python-based codes. Okay, so when you see, when you hear or when you read about topics about artificial intelligence, there are various terms and concepts comes into play. For example, we have artificial intelligence. Sometimes it is referred as a machine learning and deep learning, etc. So, what are they actually? So if you see artificial intelligence, it is the bigger subset, and it's nothing but a systematic application of various concepts, right? So, for example, you want to create an autonomous system in place. To make it an autonomous, you can either use a rule-based one or a machine learning-based one. The ultimate goal of an AI is to give us a completely autonomous system in place. Okay, for example, let's take a self-driving car. Okay, and in the self-driving car, if you go and if you try to unpack it and see what is happening, you will see a software which are actually built on machine learning. So there are various deep learning packages, deep learning algorithms which tries to grasp the visual feed that is coming from the camera, and this visual feed is being processed by a set of machine learning algorithms which understands what is there in this visual feed, and based on that a decision has been taken. Okay, so an easy analogy is that a human can be considered as an AI, as a system, whereas a brain that powers us can be considered as an ML, or machine learning. So as I said before, so machine learning is the brain that powers the artificial intelligence, right? And there are various types of algorithms of machine learning that's been developed from 1950 onwards. And so machine learning is colloquial term is referred to as something like a non-deep learning based ones. Okay. For example, random forest, XGBoost, etc. uh, they can be called as a machine learning algorithms. And as a whole, machine learning can be used to refer some of the algorithms, like whether it's a deep learning based or a non-deep learning based. Okay, but when you talk about deep learning, it's an advanced version of a machine learning. Okay, so the basic idea is that it mimics the functioning of your brain. For example, neural network has been invented as early as 1945, but the concept has come into play and it's been explored much from 2015 onwards. That's because of the computational capacity we have and access to the GPUs, etc. So these are the different terms mostly we will encounter when we talk about artificial intelligence, all those things, right? Moving on. So why we need AI and machine learning today? We know, why didn't we explore that a decade before in detail? Okay. For example, the earlier that is based on the challenges faced by the earlier systems. So they are mostly rule-based systems, right? For if you have a problem in hand, mostly you will define a rule, and this define a rule has to be executed, and based on that you will get an output. So this is most of the systems, 99% of the systems are rule based ones. So what happens if there is a numerous scenarios? So in this case, you cannot sit and write a lot of rules, and it becomes very cumbersome, and it efficiency it's degrades, and you need to modify the rules periodically. So it's a lot of work is involved, and also the volume of the data handled. is also increasing, right? So earlier we had megabytes, now it's terabytes, or more than that, it's becoming a norm. So we cannot simply define a rule-based system which is going to fail when we are handling a large volumes of the data. And also there's an expectation is moving from the results, just a result, a temporary solution to a generalized solution. So these are some of the challenges which is driving us towards a machine learning system. If you see an opportunity, so as I said before, due to the computational capacity and the technology we have, we are able to create a generalized solution by looking into the numerous volumes of data. Okay, so this unravels a lot of intricate links which is not able to identify us but the earlier rule-based ones. So with the ML model, you can identify intricate links between the data. So this is another opportunity, and based on the computational capacity and innovations and technologies, we have plethora of an R&D that is happening in the space, and you can see every day there is a research paper with a new technology or new algorithms that is coming out in the deep learning space. Yeah, so technology is the co-driver for this thing, and also the R&D. So these the challenges and the opportunities are driving today's world to adopt machine learning and deep learning in detail. Okay, so let's see a simple scenario. So let's say you have to build a model which is going to predict a house price, and the model is it depends on only two parameters. Let's say number of rooms and square feet. Then it will be very easy for you to define a rule. Let's say this is based on y and d, and it's going to be some x, some constant of y plus, let's say, some constant of d. So this could be a simple rule which you can define that, and based on that you will be able to get a simple prediction. So what happens if your house is located in a complex area and there are various factors that is affecting it? So in that case, it is not possible for us or economical for us to define a rule-based engines, right? So if you define a rule-based one, it's going to fail in the long run. Maybe its usability it's less than 1 or 2 months. So in that case, we need to look into some generalized solutions, and the machine learning is the only best option which we have, and it gives us a generalized solutions based on which you can able to predict the housing price based on various parameters. Right. So this is a simple example based on, so there are a lot of examples where machine learning actually outperforms any type of a rule-based engines. And as I said before, the data, in addition to the volumes of the data, we have different forms of the data. Variety of the data has increased. Earlier, we might be working on numerical and categorical. Now we are working on text-based, audio, image, trends, social media data, and time. So actually, the plethora of the data has increased, right? The source of data and the different forms of data has increased. And so rule-based engines may not actually work on some of these data assets, but machine learning and deep learning has been designed in such a way to garner information from all these data. Okay, so before going into what are the stages of machine learning, let's look into what are the options we have to build machine learning models. So the best thing, the most prevalent one is the Python. So Python, why Python? Because it's a high level language and it's easy to learn, and its learning curve is very, it's not that steep. And it has, one of the main thing is that the community support and the extensive availability of machine learning and the machine learning supporting libraries as part of this ecosystem. Okay, so wherever there is a deep learning module that is being released, it will be released in Python as the primary language. And it is over the top of many low-level language like C, C++. For example, NumPy sits over the top of C Python, right? So it also efficiently utilizes the power of the low-level language as well. Whereas R has came out of academia and is more statistically focused, and later based on the ease of use, the people or researchers have brought in machine learning concepts into that. And R is also a good alternative to Python. Whereas if you're working on a big data environment and you need to build a machine learning model, then let's go for the Scala. So basically, it's part of Apache ecosystem, and it's part of the big data. So its learning curve is a little difficult compared to Python and R, but it's when you're working on big data, it's recommended to use Scala. And for advanced practitioners, we can go for C++, Java. So since they are low level language compared to Python and R, so they will be more efficient in terms of executing loads. So therefore, so this is for advanced package. So once you have mastered Python, it's good to have a C++ skill as well. Python Anaconda distribution is the stable distribution, and it's very good for data science. As part of this distribution, you have various data science packages that's coming. For example, NumPy for numerical computation, SciPy for statistics, Bokeh for visualization, Pandas, Matplotlib, etc. So you need not have to install these libraries. So they are coming as a part of Python package, Anaconda distribution. So let me show you how to install that. So go to anaconda.com, and in anaconda.com, click install. So after that, you can see the page where you have an option to install Python version 3.7 and Python version 2.7. So go with Python 3.7 version, because Python 2.7 is depreciated and there is no more support for that. And try to install that. So once you click that, you will get the uh, exe file download. So you can download that and then install that like any other application. So you can select whether Windows, Mac OS, or Linux. Now it's an easy to widget that will open, and you can follow that and then install the Anaconda package. Once after you have installed, you can check whether it is installed by typing Anaconda. So there are two options for use. One is the prompt. So it's a prompt is a kind of a shell for Anaconda, and you also have Anaconda Navigator. So when you click that, you will get the Anaconda Navigator page. So it shows all the applications that is coming as a part of Anaconda distributions. Okay, so let us wait for some time to open it. So till then, if you go to the prompt, the cell version of Anaconda, you can actually use it to install the package. Okay, so our Anaconda Navigator has opened, and here you can see various applications: Jupyter Labs, Jupyter Notebook, etc. Spider is a kind of an IDE. For example, for Java, you might have used Eclipse. So similar to that, you have an IDE version, or if you want to open a Jupyter Notebook, you can use that as well. So these are add-on applications, and you can also open Jupyter from your start. So type in Jupyter and you will have Jupyter Notebook. I have already opened that. So it will run this command prompt, and then you will get this page, a landing page of Jupyter. So here you will have all the folders associated with the base working directory of this one. And then you can open a new Python notebook. When you click this, a Python notebook will open. Okay, so let us try it again. So when you click this, you will get the Python notebook. So you need to see this one. So if it is dark, then it is busy. If it is a hello circle, then it means it's available for us to write codes. Okay, and you can rename it here. Rename it. This is your Python code file, and you can import the package. So first thing first, you need to import the package. Okay, for example, let's say you are importing NumPy, which is for numerical computation. You can provide an alias name if you do not want to use NumPy again and again, or you can use without an alias. So as that is based on how comfortable you are with. So these are the two packages I'm trying to install them. So if you want to import a package which is not there in a Jupyter, you can go to the command prompt. Okay, there are two options for you to install. One is to pip install the package name. Let's say NumPy. NumPy is already installed, then it will says that it's satisfied. The condition is satisfied. Okay, or you can also do conda install NumPy. So they are more or less same. So the wheel that is running behind, it's a little different. So they both have the similar functionality. They're trying to install the package into your Anaconda distribution. Okay. So these are the two options. So after you have imported these packages, you can actually try and call the alias you have provided and press the tab. You can see the list of different commands that is associated with the NumPy package. Okay, so these are the list of commands that is associated, or methods that is associated with the NumPy. You need to select the tab button, okay, with the dot. So let's say you want to generate a random numbers based on a normal distribution. Go ahead and use random. Random is one of the sub module of NumPy, and again a dot, and then normal, type normal. And if you are not sure about what are the parameters of this method, use shift tab and it will tell you a signature. It will show the signature, and based on that you can actually provide that. Let's say you want to generate 100 numbers based on random normal distribution, and this will be your output. Okay, and you can use pandas to read Excel or a CSV. So there are a lot of read options here. You can see it can read from clipboard, CSV, Excel, and various other formats like JSON, HTML, etc. So let's say you want to read an Excel file. If you have your file placed in your current working directory, then you can check that out, and you can put the name of the file and run it. If at all you have your file placed in some other folder, you need to provide the path. Let's say uh, this is the path of this Excel which I have, and you need to provide that path and then provide the file name and provide proper extension. Okay, and now if you enter it, it's trying to read that Excel. So based on the volume of the Excel, it will take some time. Now this Excel file, the content of the Excel file is displayed inside the Jupyter, and these are the columns and rows. You can actually insert it into a data frame, a variable. Okay. Now, if you check the type of it, as I said before, the darker circle means it's busy. And if you check the type of it, it will say that it's a pandas data frame. Now we can go ahead and explore this pandas data frame and check the first top 5 rows. And if you want to check the column names, you can go ahead and type the columns and check what are the columns is available as part of it. Okay. And you can also check the bottom 5 rows, and if you put a number here, it will display the number of rows. Okay, so there are various functionalities associated with the pandas and NumPy. We will look at them in detail when we are looking at that particular course, and as part of this initial session, we will just check the basics. And moving on, so we have seen pandas and NumPy. What are the other packages that's available? So there are a lot of other packages like scikit-learn for machine learning, SciPy for statistics, and then various other deep learning based frameworks like TensorFlow, MXNet, Keras, PyTorch, etc., which we will explore when we are working on deep learning packages. So if you see the ML life cycle, so this is the life cycle, typical life cycle. You need to extract the data. Data forms the core of your prediction, right? So the data will be residing in different source systems like a SAP system, support systems like Salesforce.com, and it could be in the internet, etc. So you need to get a proper data extraction strategy, and based on that, you're going to extract the data for your prediction. The next stage will be your data pre-processing. So this is stage one, and this is your stage two, which is your data pre-processing. And most of your time you're going to spend in this because the quality of the data that's coming from data extraction could not be in an ideal format for you to run the machine learning model. So you need to clean it, you need to find the missing values and impute it, and do all the data pre-processing steps that's part of this step. So the most of the time you will be spending on preparing the data for your machine learning model. The subsequent subset of that is the feature engineering. Let's say you have a data set which has the hundreds of thousands of columns, and this may not be recommended for you to feed to your machine learning model because it will suffer from curse of dimensionality. So, so in that case, you need to reduce them, you need to shrink them using various dimensionality reduction algorithms, which we will see when we go to those courses. And also, if you are expert in domain, you can also create latent features which is not visible in this 100 columns, but it's hidden somewhere else. So latent feature creation, etc. So the next step, subsequent steps, is model selection. So that's where you need to understand what are the advantage and disadvantage of the model, which particular algorithm will work well in certain set of the data, which doesn't work well. So this kind of an understanding should be there. For example, support vector machine cannot handle a huge volumes of data, but it is very good when to draw a decision boundary when the data is very small. So those kind of difference between various algorithms should be master them so that you can use them whenever it's required. And subsequent steps are iterative in nature. So after you build a base model, then you will work on the top of it, right? So you will validate it based on the result. You will go and fine tune it, and so this is an iterative process. Even after putting into a real time scenario, you will still have uh, you need to come back and then fine tune it based on the result in a real time scenario. So this is roughly stages of machine learning, and we will, as a part of the course, we will cover these when we are working on these particular topics. So, so there are two main branches in machine learning. One is a supervised and unsupervised learning. So when I talk about supervised learning, as the name says, you have some guiding principle to guide the training process. So inputs have features, have what is the expected output or a target or a label. So this guiding principle will be used and exploited for training our model. Okay, so the model will understand, okay, the x value is this much, y value is this much, based on this the target is this much. So it learns it, there is some values for it to learn and the output for it. So this is supervised learning. And in supervised learning we have various algorithms. For if we are working on continuous values output, then you can go with the regression based algorithms. And if you're working on classifying into, let's say, class A and class B, then you're going to classification algorithms, and these are some of the examples, and there are a lot of other algorithms that can be used in this place. What in a scenario where you do not have a label or a target or a feature for a set of inputs, then in that place we need to go for an unsupervised learning. So it's nothing but kind of clustering them and identifying based on the some of the characteristics of the features. For example, let's say you have a retail shop and you want to cluster your customers based on some of the characteristics of their buying patterns or where they come from, etc., etc. So in that scenarios, you do not have a label, but you can use a clustering algorithm to cluster them into different buckets and then go and look into a particular cluster and see what are the characteristics that relates them together. And there are advanced version in deep learning space. We will check them when we are moving into when we are actually looking into deep learning. And these are some of the examples like self-driving car. It's not a single system. Inside the system, you will have a lot of machine learning, deep learning algorithms like convolutional neural network, which looks into image-based data, converts this image-based data, and extract the feature and send it to a subsequent algorithms. Similarly, other system, AlphaGo, has reinforcement learning as the brain, which is a little bit different from the conventional machine learning model, and various other systems always leverage some combinations of different machine learning and deep learning models to give a complete autonomous system. And also, there are a lot of companies that are exploring how to apply this machine learning, deep learning in their business process and bring business benefit to their process. So you can see these are some of the examples, right from Airbnb to Facebook to Walmart, Coca-Cola, BMW. These are just a handful of examples. In the current world and the current timeline, you can see thousands of companies which is exploding. So this is the space where the innovation is happening nowadays. Yeah. So as a part of the conclusion, we will see. I will give some of the exercises which you would need to go and execute it, and come back in the next the subsequent classes. You can see what are the solution for them. So these are some of the basic exercises so for you to run the Python program, right? So you set up the environment for your Python program. For example, first exercise for you to install Anaconda distribution of Python and run a Jupyter. So download Python exe and install that, and then try to run the Jupyter notebook. Second thing is to install a Python package. Check if there is any other package that is not part of Anaconda distribution. Try to install that using pip install package in your Anaconda prompt. Then check the list of methods as part of this package. The third step is to check the methods associated with the package. And the fourth exercise for you to import pandas, which is already there as a part of Anaconda distribution, and try to read a CSV file. Have a CSV file in your current working directory and try to read a CSV file, and then try to check only the first 5 rows of the CSV file. So these are the exercises as part of this session. I hope you will work on them. And in the subsequent session, we will look into some of the other topics. So thank you.